So today I'm in Albuquerque, New Mexico at the New Mexico Museum of Natural History and Science, and we are going to speak with Dr. Larry Crumpler today. He is the person who is in charge of the Land Rover on Mars. So come on. So Dr. Crumpler, I'm just curious, how do you get a vehicle like this? Does it fold up and then unfold?
Yeah, basically it was a nice piece of metallic origami. It folded up into a very nice little triangular package that once it got to Mars in the form of a little cone-shaped package, the package unfurled and it had airbags that it used to sort of bounce its way down to the surface. And then those airbags deflated, and then the package unfolded. The first thing that happened was the sides of the lander came down, and so it looked like a flower petal. And on it were sitting just a little box with little stubby wheels. The panels, the solar panels came out unfolded, came out this way, and then the other piece folded over that way. The mast here was on the deck, and it rotated up into position, as did all of the other devices like the radio communications device you see here and the antenna there. Then the wheels basically then expanded. The front wheels were tucked in like this and then rolled out like that. So it sort of expanded like transformer style to the condition you see now. So it was a considerably smaller package.
So do you test these things here in the desert somewhere?
Yeah, we actually had a field test before the actual mission. In fact, we actually had several, in which we trained on how to operate the rovers efficiently on the surface of Mars. And we had one in an area not too far from the Grand Canyon, actually, a very desert area, where we basically were in a room at the Jet Propulsion Lab. The rover was in the field, and we operated it as though it were on Mars. And we were able to determine all sorts of interesting things about the geology of the Southwest from just our little trek that we did on that little training exercise.
So what is this particular part of the rover?
This is the device sticking out here is called the IDD, or Instrument Deployment Device, or the rest of us would just refer to it as the arm. And on the end of it, it has a series of instruments that rotate around. And the one that's facing the rock now is a device called a RAT, or a rock abrasion tool. And that's kind of the substitute for our rock hammer of a geologist. It grinds into the rock and exposes fresh surface. And then a couple of the other instruments. There's one on the backside you can't see that's a microscopic imager that looks at the rock, literally makes images that are only a couple of inches across. You can see individual grains. Then there are a couple of other instruments that measure various things about the chemistry of the rock, the iron mineralogy, and so on. So we can do all of that with this instrument, and then it basically folds up under the spacecraft for driving, and then we unfurl it at the end of the day. Currently, Opportunity has a problem with its motor on the so-called shoulder joint, so it's a very difficult instrument to use for Opportunity. On Spirit, on the other side of the planet, the RAT wore out on Sol 400 or so, or thereabouts, or Mars Day 400. And both rovers are having trouble with one or more motors. Spirit has a front right motor wheel that is no longer operative, and Opportunity is maybe experiencing some difficulty with one of its wheel motors. But by and large, the spacecraft, considering they're in a harsh environment, a place where it gets minus 80 degrees in winter, a place that's dusty, totally dry, hundreds of millions of miles from Earth, they're doing quite well for that condition.
So what is this particular part of it right here?
That's an antenna that we use to actually send the signal directly to Earth, or we can communicate with the spacecraft directly to Earth or from Earth with that. So it's just one of our communications antennas, and it's an interesting one. It's steerable, so it's like it's like your satellite dish. It basically can move around and face different directions. And an interesting fact is that because of the mast of the panoramic camera here.
And this is the camera up here.
Those are the cameras up there. There are two high-resolution color 20/20 vision stereo cameras, and then there are two little smaller ones that make nice black and white images that are easier to get, so they're smaller, but so we get those a little bit more. Basically, that assembly there sometimes gets in the way of this antenna. When we're sitting on a slope and the Earth comes up over the horizon and we want to communicate with the Earth, the antenna literally is kind of like looking from side to side, trying to see around the big the mast here. So early on, we had to learn how to park the rover so that when the Earth came up over the horizon in the morning and we wanted to communicate with it, we would not have that problem. So there's a lot of little learning experiences like that involved.
So let me ask you a little bit about yourself. Were you one of those little kids that dreamt about, are you living a dream come true? And you work with a crew that is all over the United States. Is that true?
That's right. I was the typical kid interested in astronomy and geology and anything else involving the natural world. And one thing that kids who are coming along who want to know what they should study to do this sort of thing is that I, at the time, didn't know whether I should be doing astronomy or whether I should be doing geology. And it turns out that when I got to the point where I had to kind of make a decision, I realized that really what I was really interested in was the surface of the planets. And so I went into geology. And then at about that time, there was a lot of development in spacecraft going to the other planets. And so there was sort of a natural sort of connection between astronomy and geology at that point called astrogeology. And so it's basically turned out that a lot of geologists are working on the surface of other planets with rovers like this or with other spacecraft like the Mars Reconnaissance Orbiter or Odyssey spacecraft, both of which are in orbit about Mars right now. So it was a long process, but just staying focused on what it really was that interested me enabled me to be a part of this. But the team itself does consist of a number of scientists from not only throughout the United States but around the world, and we meet on a daily basis to interact with the rovers and basically explore the surface of the planet like 19th century explorers of the American West. We meet by telecon. We send lots of data by various internet softwares, including email. And we have meetings by telecon to discuss what the rover has seen and what we would like the rover to do on the next day. So it's a very successful way of operating these missions without having to have everybody in the same room, although we did that for the first 90 days.
So this is a project of NASA, and NASA is an arm of the government?
Yeah, this is, of course, a NASA project. It's part of the Solar System Exploration Program of NASA. And it's basically funded by the government as part of the program. It's a small part of NASA's budget. Most of it, of course, goes to all sorts of other things, including manned spaceflight activities like the shuttle, as well as aeronautics applications, and a whole truckload of other missions that are going on to other planets, including Saturn and other planets and other things, as well as Earth orbital observations associated with climate change observations. So this is a small part of the NASA budget. We're just trying to explore the solar system with the tools that we have, and this tool is basically a field geologist turned into a robot and sent to another planet.